Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is find a corresponding node of a binary tree in a clone of that tree. Okay, so let's read the description. So we have given the two binary trees, original and a clone, and we have given a reference to a node target in the original tree. Okay, so you can see we have two trees. One is your original and another is your clone, and you are given one more thing, that is target node. Okay, the clone tree is a copy of the original tree. Okay, so it's the replicate of the original tree. What you have to do, you have to return a reference to the same node in the clone node. Okay, note that you are not allowed to change any of the two trees or the target node, and the answer must be a reference to a node in the clone tree. Okay, so what is given to you? You have given two tree. One is original and other is clone. And clone is, like, you can see all the values are same in this tree also. And there is one more thing, that is target, and target is reference to your original tree. So if you search your target node in the original tree, you will find it. But if you search your target node in the clone tree, you will not find it, because the address or the reference of that node will be different. Like, value will be same, but reference will be different. So what you have to do, you just have to search in the original tree, and with respect to your clone tree, you have to return the reference of the clone tree. Okay, so if you can see, we have target of 3. So we will search, like, we will go by both direct, like at both the same time. So let's say we will start from 7. This is our root node for both. We will search in the left part. If we find the node, we will return the clone node. We will not return the original node, because we have to return the clone reference. And if we didn't find the node in the right part, oh sorry, in the left part, we'll search in the right part. Similarly, we'll go deeper. So you can follow any approach, like pre-order, in order, post order, and level order you can also follow. So that's up to you, you can use. So, and if you can see for other example, so this is example 3. So we have a given target as 4 as a reference. If we search in the example in the original tree, it's in the right of the 8. Okay, and similarly you have to return the clone reference of that 4. So it's just a simple implementation question. So if we just do it like this, so if our original is equal to target, we can directly just return the clone node. We don't need to do anything. Okay, because we need to return the clone reference, but we are searching for with respect to original tree. Okay, now we apply uh, any, you can say, let's say we will apply the pre-order. So what we will do, we will basically take a variable and we'll call the left part. So get target copy, and we'll call both of the left. So we'll call original dot left and we'll call the clone dot left, and we'll pass the same target node. Okay, so after solving to the left part, let's say you didn't get your answer, so you are getting a null. Okay, so if you are getting a null, you will search in the right part. But let's say you got the result, then you don't have to search in the right part. So basically it will help us to not call the right part if we find the answer in the left part. Original dot right and cloned dot right, and we'll pass the target, and finally we just return the node if we got the output. Okay, yeah, that's it. Okay, we need to add one base condition, that will be let's take it at the top. So if your original become null, that means you didn't find the node, so you just return the null. Okay, let's run it. Oh, why it is signing in it again? Just give me a second. Okay, let's run it. So this is accepted. Let's submit it. Okay, so yeah, our code is submitted. Our time complexity is, it's a pre-order, so we traverse at max all the nodes, so it's a order of n. And space, we are just using a stack basically recursion stack space. So that's the space complexity. So hope you like it. Thank you for watching my video.